Hi, welcome to PlayOwnAI. It's Mateen. We'll build AskMyDocsSlack, that AI-powered chat with your data in Slack. It's simple, smart, and real-time.
MyDocsSlack. Chat with your data in Slack. Quick setup guide.
Now let's execute final workflow. AskMyDocsSlack. Chat with your text data in Slack automatically. No manual searching. No repetitive work. Just text data upload on Google Drive or cloud storage. Lets your AI Slack chatbot respond intelligently from real documents. Now let's see just how simple it is to use our AskMyDocs bot. It all starts with a simple / command. I'll type -AskMyDocs, which is our trigger for the bot. After the command, you can just ask a natural language question. For example, -AskMyDocs, what is breakfast, lunch, and snacks policies? And just like that, the bot goes to work. It processes the request, searches our internal documents, and instantly provides the complete policy directly in Slack. No need to leave the chat, search through files, or bother a coworker. That's the power of having your own AI-powered knowledge base right within your team's workflow. It's that simple, smart, and real-time. What you'll learn. Video goal. What you'll learn. Build a complete RAG, Retrieval-Augmented Generation. Build a fully functional Slack bot that can answer questions based on your private company documents. Orchestrate the entire workflow using NN, connecting Google Drive for private data, Qdrant as a knowledge base, and OpenAI as the AI's brain. Empower viewers to turn their own documents into a powerful automated assistant. All right, let's start building this in NN. First, go ahead and create a brand new workflow. To keep things organized, we'll immediately rename it to AskMyDocsSlack. Now, to begin our workflow, we need a starting point. Let's add our very first node. We're going to add a manual trigger node. We'll use this particular trigger to test our workflow from inside NN as we build it, making sure everything is working correctly before we connect it to Slack.
Add node Google Drive node that brings in our data. We'll use this node to download the .txt file containing all of our source data. Now, for this to work, you'll need to make sure your OAuth credentials are set up correctly, which allows NN to securely access your Google Drive account. It's also important to ensure the specific file we're using is accessible and has the right permissions. For this demo, we'll be using a sample HR policy document as our source of information. This document is what our AI will learn from.
With our document now downloaded from Google Drive, we need to feed it into our AI's memory. For that, we'll use a Qdrant node. Once you add the Qdrant vector store node, click on it to open its subitems. From the drop-down menu, select the operation Add Documents to Vector Store. This tells N8 to take the content from our Google Drive file and upload it into our Qdrant knowledge base, making it searchable for our AI. Qdrant Cloud Portal. Now, let's set up your Qdrant account. Go to cloud.qdrant.io and click Sign Up at the top right. You can use your email, Google, or GitHub to log in. Click Create Cluster to launch your own vector database. Name it something like AskMyDocs, choose a region near you, and click Create. Wait a few seconds for initialization. Now that our Qdrant cluster is ready, we need to create an API key so NN can connect to it. Go to the API Keys tab and click on Create API Key. You'll be prompted to give it a name. I'll call mine NN Access to make its purpose clear. And here is the key. This is a very important step. You need to copy this key right now. You will not be able to see it again after you close this window, so copy it and keep it secure. This is the key you'll use inside NN to connect securely to Qdrant. After establish your credential, NN securely connects to your Qdrant instance. Credential to connect with Qdrant API account. Next, you'll select the operation mode. For our purposes, we're going to focus on ingesting data into the vector store. Operation mode, insert documents. This mode tells the node that its job is to take the documents from the previous node, which you've likely processed with a text splitter and an embeddings model, and store them in Qdrant. After that, you'll specify the Qdrant collection. This is the database where your vectors will be stored. You can either choose an existing collection or have NN create one for you. We'll be using a specific collection for this example. Qdrant collection HR book. And finally, a very important parameter for performance is the embedding batch size. This setting determines how many documents are sent to Qdrant in a single API request. With our document downloaded from Google Drive, we need to properly load and prepare the data before we can embed it. We'll add node the default data loader node for this task. Let's configure its parameters. First, for type of data, make sure you select binary. The file we downloaded from Google Drive is in a binary format, so we need to tell N8N how to handle it. Next, for mode, we'll choose Load All Input Data. This ensures that we process the entire document, not just a portion of it. Finally, for data format, we will select text. We're telling the loader that even though the file is binary, the content inside is standard text that can be read and understood by the next nodes in our workflow. This node will add node LangChain's recursive character text splitter node. This is an incredibly smart tool. It works by breaking the document into chunks, not just at a single character, but by trying to split at paragraphs, sentences, and words in that order. This helps to keep the chunks meaningful. For our example, we're going to set the chunk size to a reasonable amount so that our embedding model can process it efficiently. We'll set our chunk size to about 5,000 characters each. Now, to make sure we don't lose the context between these chunks, since a sentence. After clicking on Execute Workflow from Webhook, our data is now being processed and inserted into our Qdrant vector store collection. To verify that everything worked correctly, we'll head over to our Qdrant dashboard. You should see our collection listed here. We're looking for our collection named Name HR Book, and you can see the stats. The status is Status green. This confirms the collection is active and healthy. The most important metric for us right now is the number of points, or vectors, that have been added. Points approx 8. This number tells us that our document has been successfully split into 8 chunks and stored as individual vectors. We can also see other details like the number of segments and shards. Segments 2. Shards 1. These are back-end details that show how Qdrant is internally managing our data. To get even more details about the vectors that were inserted, we can click on the HR book collection. This view allows us to inspect the individual vectors, their payloads, and other metadata, confirming that our workflow ran perfectly and the data is now ready to be queried for our RAG application. Now, we're going to create the second part of our project, the chat interface that will actually retrieve data from the vector store we just built. This workflow is what the user will interact with. To begin, we'll add the chat trigger node. This is the starting point for our chatbot. This node is special because it's designed specifically for chatbot interactions. It listens for incoming questions from a user and serves as the entry point for our entire retrieval and generation process. For this demonstration, we'll keep the default settings. The standard configuration works perfectly for a basic chatbot. With the node in place, our workflow is ready to accept user input. The final step is to get the webhook URL for this trigger. This URL is the critical link between our N8N backend and our front-end chatbot, whether that's a simple HTML page, a custom-built widget, or an existing service. We'll copy this webhook URL and use it to connect our front-end chatbot. When a user types a message in the chat, it will be sent to this URL, triggering our N8N workflow and allowing our RAG pipeline to retrieve a response. And with that, the retrieval side of our RAG workflow is now configured and ready to be connected to an actual chat interface. The next step is to build out the logic that will use this user question to query our Qdrant vector store. Now add node to bring in the Qdrant vector store node. This stores your embedded chunks and acts as the knowledge base. Connect your Qdrant credentials and select your collection, for example, HR book. Add the OpenAI Embeddings node again to convert user questions into vectors before searching Qdrant. Connect this node to the Qdrant vector store. Add node the Q&A chain node. This is the heart of your RAG workflow. It takes the user's question, retrieves relevant content from Qdrant, and sends it to OpenAI for answering. Vector Store Retriever node. This searches Qdrant and returns the top 8 matching chunks. Link it to both the Embeddings node and the Q&A chain's retriever input. Add the OpenAI Embeddings node again to convert user questions into vectors before searching Qdrant. Connect this node to the Qdrant vector store. Let's add the OpenAI chat node to our canvas. Once the node is on the canvas, we'll configure it. You'll need to select the model you want to use. You can choose from any model available in your OpenAI plan. For a good balance of speed, cost, and intelligence, a great option is use GPT-4 Mini or any model in your plan. For now, we'll leave the other settings at their default values. These defaults are typically optimized for common use cases. The final step is to connect this model to our Q&A chain. Now for the exciting part. Let's test our complete Retrieval-Augmented Generation workflow. We've built the full pipeline, and now we'll see it in action. I have a simple front end here that is connected to the chat trigger webhook URL we copied earlier. Let's ask a question that we know is specifically covered in the documents we ingested into Qdrant. I'll type in, "What is general conduct?" When I send this, the N8N workflow is immediately triggered. It takes my question, uses it to find the most relevant document chunks from our Qdrant vector store, and then sends both the question and the retrieved context to the OpenAI chat model. If we deleted collection HR books, ask same question, it can't answer. And there we have it. The workflow provides an answer that is based directly on the documents we gave it. This is the core function of RAG. It's not just making up an answer, it's providing an answer that is grounded in my specific text or documents. This demonstrates that our entire pipeline is working correctly, from the initial chat message all the way to the final accurate response. Now, execute workflow from webhook. Our data is now being processed and inserted into our Qdrant vector store. Ask same question it can answer. Now, that can listen for a question, retrieve relevant information from our vector store, and use a powerful language model to formulate a final intelligent response. Now that we have a working RAG workflow, let's connect it to a real-world application, Slack. This will allow our team to ask questions and get answers directly from our documents right within our workspace. The first step is to create a new Slack app. We'll start by visiting the Slack API Quick Start page. Visit https://api.slack.com/quickstart. From here, we'll click on the Your Apps button at the top right of the page. Now a pop-up window will open. We'll select From Scratch to build our app from the ground up. We'll give our app a name and choose the workspace we want to develop in. App name, My Slack Apps. Pick a workspace, BDCROPS. Now we'll grant our app the necessary permissions.
In the left-hand menu, navigate to OAuth and Permissions. Under Bot Token Scopes, we need to add a few permissions so our bot can read messages and respond. We'll add the following. Channels.read. This allows our app to view basic information about the public channels in our workspace. Chat.write. This is the crucial scope that lets our app send messages as our bot at MySlackApps. Commands. This enables us to use slash commands, which will be the trigger for our RAG workflow. With our permissions set, let's create the command that will trigger our workflow. On the left menu, click /commands. Here, we'll fill out the details for our new command. Command /AskMyDocs, or /AskHR, or simply @HR. Short description, AskMyDocs. Request URL. We'll add a webhook node to our workflow and copy its test URL. Now we can paste that URL into the request URL field for our / command. Request URL. Paste the URL from NN here. Usage hint. AskMyDocs HR policy. This provides a helpful hint to the user on how to use the command. Before we can complete the Slack setup, we need a webhook URL from NN. Let's go back to our RAG workflow. For a better user experience, we want to allow users to interact with our app directly. On the left menu, click App Home. Make sure to tick the checkbox that says Allow users to send / commands and messages from the Messages tab. Almost done. The last step is to install the app to our workspace. We'll click Install to Workspace, and then on the pop-up, select Allow. Now, let's open a Slack chat window. In any channel, I'll type our new / command. /AskMyDocs. You can see that a response comes back confirming that the workflow has started. This means our / command successfully triggered the webhook in NN. From here, we can build the rest of the NN workflow to send the user's question to our RAG pipeline and get an answer back.
We've successfully created a workflow that gets triggered by our webhook. Now we need to make sure we're correctly pulling the user's message from that webhook to use as our prompt. In the next node of our workflow, which is doing the work, we'll configure the source of our user's message. Parameters, settings. Source for prompt, user message, defined below. Now for the actual prompt, we'll use an expression to pull the text field from the webhook's body. The text field is where Slack puts the user's message. Prompt, user message, @json.body.text. We can now execute this step, and as you can see in the output, it returns the response. This is the answer we want to send back to Slack. Now, to send this response back to the user in Slack, we need to add an HTTP request node. This node will make an API call to the response URL that Slack provided in the original webhook payload. This URL is a one-time use address for sending a reply to the user. Let's configure its parameters. Parameters, settings. Method, post. The response URL requires a post request, so we must set the method accordingly. Next, for the URL itself, we'll use another expression to dynamically pull the response URL from the initial webhook. URL @/webhook.item.json.body.response URL. The Slack API expects a JSON payload, so we'll set our body type. Body content type, JSON. And we'll tell the node we are defining the body using a field. Specify body using fields below. Finally, we'll define the JSON body that we're sending. The key for the message text is text. Body parameters. Name, text. And for the value, we'll use an expression to pull the response from the previous node. Value @json.response. With this configuration, our workflow now does everything. It's triggered by a Slack command, it processes the request, and it sends the final answer back to the user in Slack using the provided response URL. We have successfully tested our workflow using the test URL from the webhook. This is great for debugging, but the test URL is only active while the workflow is open and you're listening for a test event. For a production environment, we need to use the permanent production URL. First, let's get that production URL. We'll copy the production URL from our webhook node. This URL will be active as long as our workflow is activated. Now, we must activate the workflow to make this URL live. With our workflow active, let's go back to our Slack app settings to update the command. We're going to edit the / command we created earlier. In the request URL field, we'll replace the old test URL with the new production URL we just copied from N8. Request URL. Paste production URL here. With the new URL saved, our Slack command is now pointing to our live NN workflow. Now let's ask our question again, but this time the request will be handled by the active production workflow. I'll type in a question that relates to our document. /AskMyDocs, what is dressed code? And there you have it. The workflow returns a response based on our document files, confirming that our Slack integration is fully operational, from the user's command to the RAG pipeline and back again. Our RAG bot is now live in our Slack workspace. Support line, Get Assist. Stuck anywhere or feeling overwhelmed? No worries. You can download the full workflow directly from my GitHub. Just follow the link in the description. TV, for more tutorials and smart automation tips, visit my YouTube channel at PlayOwnAI. Still need help? Feel free to drop a comment below. I personally reply, and I'm happy to assist. Thanks for watching. If you found even a bit of value, please subscribe and hit the bell. We release new videos every week. Let's build smarter together with OpenAI Playground.